Hello students, in the following videos we are going to talk about the chapter of chemical effects of electric current. In this session we are going to talk about good and bad conductors and the effect of electric current on liquids. As you know, we will be dealing with electric current and chemicals, so I must advise you and warn you that you must not play or experiment with the current from the mains, that is the switchboard or inverters or generators or anything such as that. You should wear gloves while handling with chemicals as well as electricity, and if possible try to do this experiment in the guidance of a teacher or an elder. Before we learn about the chemical effects of electric current, we must first know about the properties of materials and its relation with electricity. You might already know about it, but I will be reminding you about this. Any material which allows current to pass easily through it are known as good conductors of electricity. Some examples would be iron, copper, aluminum, etc. Whereas on the other hand, there are some materials which do not allow current to pass through them easily, such as plastic, glass. These things are the poor conductors of electricity. I would like you to note that poor conductor of electricity does not mean current will not pass through it. It just means that a higher voltage is required for the current to pass through it. Well, I am sure your parents or elders might have cautioned you about not touching the switches when your hands are wet, or you should wear slippers while you are handling electrical devices. You may also have heard the unfortunate instances like people passing by an electric pole and getting electrocuted while it was raining. Why and what must have caused all this? Looking at what happened, you must have already understood that here in this case the human body acted as a good conductor of electricity, so the person got electrocuted. The same reason applies to why our parents tell us not to touch the switches while our hands are wet, whereas they also tell us to wear chappals while we are touching the switches, because the chappal is usually made of rubber, which is not a good conductor of electricity, because of which the current will not pass through our body. Well, we have talked a lot about good and bad conductors, but how do you know whether current is passing through a material or not? For that we will need a tester or testing equipment which can be used on a particular material. For this activity, we will be taking a filament bulb, an LED bulb, a compass wounded by a wire, a 4-volt battery, a chalk, a steel pin, a copper wire, an iron bar, a rubber, a pencil sharpened on both sides, a plastic cap, and some connecting wires. The connections are made as shown in the diagram. From the battery, one wire is connected to the bulb, and the other side of the bulb is connected to a free end, and the other side of the battery is also connected to a free end. So, this is our tester. So, these are the two free ends of the wire, and we will be connecting different specimens to check whether current flows through them. Now, as you see, the filament bulb has been replaced by an LED. So, you must always remember that the positive of the battery must be connected to the positive of the LED, and the negative of the battery will be connected to the negative through the conductor or the material that we are using. So, now we will be repeating the same experiment. Now, we will be connecting the two ends of the wire to the lead of the pencil. As you can see, the bulb is glowing. So, it means that this lead is a good conductor of electricity, and as you know, this tester that we have made is a better and more sensitive tester. To create an even more sensitive tester, we will connect these two ends with a compass with a wire winded around it. In this method, we will see even if a very little current is passing through it, the deflection of the magnetic needle will be visible. This method is the most efficient way to detect the flow of current in materials. Now, we will connect the two ends of the lead. as you can see, there will be a slight deflection in this compass. So, from this we know that this material is a conductor of electricity. As we need to know and understand the conductivity of liquids, let us take a liquid in the place of the material as we have shown you in the demonstrations before. Let us use the LED tester, which you can easily get at your home or nearby electrical stores. Before you start the experiment, you must know that we must always keep the two ends inside the liquid and they must be 1 centimeter apart, and whenever you put it in another solution, you must wipe it. So, for the first case we will be taking tap water. So, now let us take the two ends and dip it into the tap water. As you can see, the light bulb is glowing. So, tap water is a good conductor of electricity. So, now let us test the HCl solution. As you can see, again the LED bulb is glowing. So, this solution is a good conductor of electricity. Now, we will be taking distilled water. As you can see, the LED bulb is not glowing. So, distilled water is not a good conductor of electricity. Now, let us take vinegar. When we dip these wires in vinegar, you will see the bulb is glowing. So, from this we can also conclude that vinegar is a good conductor of electricity. Similarly, this experiment can be repeated for different solutions like lemon juice, milk, honey, etc. In this session, we have learnt about good and bad conductors of electricity as well as the effects of electric current on liquids. I hope you have understood and thoroughly enjoyed this session. In the next session, we will be talking about chemical effects of electric current on liquids. Till then, take care and stay safe. Thank you.